Hi everyone, I am Dr. G. Srinivasu, Associate Professor, Department of Mathematics, University of Aeronautical Engineering, Dundigal, Hyderabad. In the present video, I would like to discuss about the volume integrals in vector integration. So in the previous videos, we have seen the line integrals and surface integrals, and we have done many examples in the previous two topics. Now, we are going to see the topic volume integrals. So what is volume integrals? So let us define. Let f bar be any continuous vector point function defined over the region V, and V is the volume bounded by the surface. R bar is equal to f bar of u comma V. And now divide the total region V into m subregions. I am dividing the total region m subregions by drawing lines parallel to x-axis, parallel to y-axis, and parallel to z-axis. So then you'll get the, suppose if it is the cube like this, then you can divide this region into m subregions by drawing lines parallel to x-axis and parallel to y-axis and z-axis. And let us assume that the volumes of the m subregions delta V1, delta V2, so on delta Vm. And also I assume that let Pi be any point in the ith subregion whose volume is delta Vi. Let Pi be any point in the ith subregion. This is the ith subregion. Suppose if you do like this is the ith subregion. And let us assume that Pi is any point in this region and whose volume is equal to delta Vi. Now I am going to consider the summation f bar delta Vi. Summation f bar delta Vi. So this is not there, this is wrong. Summation f bar delta Vi. Then as m tending to infinity, delta Vi shrinks to a point and the limit of the above sum exists is called the volume integral of f bar in the region V, and it is denoted by integral over V f bar dV. Integral over V f bar dV. The volume integral is defined as integral f bar dV, where f bar is the vector point function defined in the region V, and V is the region and dV is the dx into dy into dz. Now let us see the Cartesian form. Let f bar is equal to a vector point function which is a function of x, y, z, that is f1 I bar plus f2 j bar plus f3 k bar, where f1, f2, f3 are functions of x, y, z. And also we have dv is equal to dx into dy into dz. dv is the volume of the small region that can be denoted as length into breadth into height. That is, small change in length is dx, change in width y, change in height z, dz. So dx into dy into dz be the volume. Then the volume integral is given by integral f bar dv, as I said in the previous definition. So the limit of the sum as n tending to infinity will give the integral over v f bar dv. So that is equal to triple integral over v. F bar means what? f1 I bar plus f2 j bar plus f3 k bar. And what is the dv means? dx into dy into dz. So this I can split into three terms as I bar coefficient, j bar coefficient and k bar coefficient. And here I bar coefficient is a triple integral f1 dx dy dz plus j bar coefficient f2 into dx into dy into dz over the triple integral plus k bar coefficient triple integral f3 dx into dy into dz. So if you want to find out the volume integral, you need to calculate f bar dv, where f bar is any vector point function. Or sometimes you can calculate the scalar point function into dv over v also. That is also triple integral over the volume of the region V. Now we will see some examples how to solve them. Triple integral means, or volume integral means, you have to calculate integral f bar dv. F bar is the given vector point function, and the dv can be denoted by dx into dy into dz. Now we have to take the integration along with the x-axis and y-axis, z-axis, as we can see in the next slide. So here the problem is evaluate integral f bar dv. F bar dv. No, not need by, this is not dot. This is simply f bar dv, where f bar is equal to the vector point function 2xj I bar minus xj bar plus y square k bar. Clearly f bar is a function of x, y, z. And v is the region bounded by these values x0, x2, y0, y6, z is equal to 4 and z is equal to x square. So region limits already given that. So no need of finding the limits once again. So problem will be simplified already. X0 to 2, y0 to 6, z x square to 4. Now to find the solution, we have to evaluate integral f bar dv. Already f bar is there. V limits also given that. Z varies from 4 to x square, y0 to 6, x0 to 2. So what is f bar? F bar means the given vector 2xz I bar minus xj bar plus y square k bar. And then the volume integral is given by integral over v f bar dv. Integral over v f bar dv. That is equal to triple integral. So f bar, you write it as 2xz I bar minus xj k bar plus y square k bar into dx into dy into dz. So f bar as it is, dv can be split as dx into dy into dz, because volume is nothing but length into breadth into height. So this can be split as I bar into triple integral xz 2xz dx dy dz first term minus j bar into triple integral x dx dy dz plus k bar into third integral triple integral y square dx dy dz. So here the limits already given. Z varies from x square to 4 and y varies from 0 to 6 and x varies from 0 to 2. So the same limits will be applied for all the three cases, and x and y are constants here, but z is a function of x. So z is x square by 4, x square to 4. So the integration must be carried out first with respect to variable limit. Here variable limit is z limit. Z is a function of x. So first we have to integrate the function with respect to z. Already we have seen in the multiple integrals how to integrate the given function in triple integral case and double integral case. So the same approach will be applied here. So I bar into 0 to, first we have to carry out the integration first with respect to z, then y, then x. First we carried out with respect to z, then y, then x, because z is a function of x. Z is a single variable limit. Y and x are constant limits. Y and x are constant limits. That means you can do integration first with respect to x or first with respect to y. That is your option. But here y limit is already given as a second place. So we integrate the function first with respect to y, then with respect to x. So you can do vice versa also, no problem. First, but we have to make the integration carried out first with respect to z. So on making the integration 2xz integration, 2x constant, while doing the integration with respect to z. So z will be the value z square by 2, already 2 to 2x. So what it will be, I will tell you. This is, here I will 2xz integration with respect to z. With respect to z means what? 2x into z square by 2. 2 gets cancelled. The value xz square, that is given directly, xz square. Limits are x square to 4. So z integration over. So the remaining will be dx into dy. That is the first term. Similarly, minus j bar into, here also we have to integrate x with respect to z first. So the integration xz between x square to 4. Am I right? So here dx into dy, dz operation over. Plus k bar into 0 to 2, 0 to 6, y square with respect to z integration. That means y square z between x square to 4 dx dy. Now, this is I bar into integral 0 to 2, integral 0 to 6, So you have to replace z for 4. That means 16x upper limit. Lower limit z for x means x power 5 dx dy. So just integrate, simplify the term minus j bar into integral 0 to 2, integral 0 to 6. Upper limit on substituting z for 4, that is 4x minus x cube. Z for x square, you will get x cube dx dy. That is the second term. Plus k bar into 0 to 2, 0 to 6. What is the limit? Z for 4. So 4y square minus z for x square. So x square y square dx dy. This is the integration with respect to z after substituting the limits also. So now we have to carry it out with respect to y or x. So already it is written first y then x. So we do integration first with respect to y. So we'll go to the next slide. So integral 16x minus x power 5 already I have written, and here 4x minus x cube simplified. Then what is the last one? Y square into 4 minus x square, right? Now on making the integration with respect to y, so x term is constant. So 16x minus x power 5, right as it is. So integral dy means y between 0 and 6 minus j bar into integral 0 to 2. So this is also complete x term, 4x minus x cube, that carried out as it is. Integral dy, y between 0 and 6 dx. So in the next step, we will substitute the limits, upper limit and lower limit, plus k bar into integral 0 to 2. So here 4 minus x square is treating as constant term. And for y square, the integration is y cube by 3. And the limits are 0 lower limit and 6 is the upper limit of dx. So up to this clear, first we integrated the function with respect to z, and we substituted the limits, upper limit and lower limit. Now we integrated with respect to y and then substituted the limits 0 and 6. Now the resultant is like this. After the substitution also, this is 6 into 16x minus x power 5 dx. It is j bar into 0 to 2, 4, 6 into 4x minus 6 cube. Here k bar into 0 to 2, 216 by 3 into 4 minus x square. So I bar into, so now on integrating with respect to x finally. So 6 as it is, right as it is, and it is 16x minus x square with respect to x integration. So 16x square by 2 minus x cube by 3, x power 5 means x power 6 by 6 between the limits 0 and 2, or 2, 8x square minus x power 6 by 6 between 0 and 2. That is the first integration. And here 4x integration, 4x square by 2. That means what? 2x square. So already it is given. And x cube integration, x power 4 by 4. So limits 0 to 6, 6 constant, right as it is. Plus k bar into, here 216 by 3 is constant, integration 4x first term, second term x cube by 3 between 0 and 2. So substituting the limits for integration, upper limit 2, lower limit 0, you will get 8 into, this is 2 square 4, 8 4 is 32 minus 2 power 6 by 6. So all will get to 128. This is j bar coefficient 24 and this is 384. So in this way, we can calculate the volume integral with respect to the given region. Similarly, we can do some exercises or some examples over the volume V. So I will go to the next slide. So see this problem. Given f bar 2x square minus 3z I bar minus 2xy z bar minus 4x k bar, and V is the closed region bounded by, so here we have to talk about the region, closed region, x, y, z axis, and the plane 2x plus 2y plus z is equal to 4. That means what? X by 2 plus y by 2 plus z by 4 is equal to 0. So the plane cuts at x-axis 2, 0, 0, and on y-axis this is 0, 2, 0, but on z-axis it is 0, 0, 4. The region is the tetrahedron. The region is the tetrahedron. So now we have to find the limits of the integration. Suppose if you consider the height limit is parallel to z-axis. So this is z is equal to 0 because it is on xy plane. On xy plane z 0. And upper limit, this is on the plane 2x plus 2y plus z. So z is equal to, the upper limit z is equal to 4 minus 2x minus 2y. So that is the limit. Now I will write the complete limits. Z varies from 0 to 4 minus 2x minus 2y. And what is the other limit? We have to consider the area. The volume is nothing but area multiplied by height. So height limit already there, z0 to 4 minus 2x minus 2y. But on coming to the y and x limit, we have to consider the area. Area means, I write this diagram x-axis. It is touching at 2, 0 and on y-axis is touching at 0, 2. So I am considering the same area in the side on x and y axis. So to find the area of this region, we have to consider the strip inside the region either parallel to y-axis or parallel to x-axis. Suppose if you this line will be 2x plus 2y plus z is equal to 4 is the plane, and this line touching at 2 means it is 2x plus 2y is equal to 4 only. Am I right? 2x plus 2y is equal to 4. Then on x-axis y0, so y limit is 0 to 4 minus 2x. That is the y limit. So this strip area we will obtain by integrating the function between the limits y is equal to 0 and y is equal to 2y is equal to 4 minus 2x, or y is 2y is equal to 4 minus 2x, or y is equal to 2 minus x. So this I can write y is equal to 2 minus x. I am cancelling out 2 minus x. But the z is equal to 0 is same as z is equal to 4 minus 2x minus 2y. This is y limit and x varies from 0 to 2. So these are the limits for integration and considering the area limit multiplied by height limit z 0 to 4 minus 2x minus 2y, and x y varies from 0 to 2 minus x, and x varies from 0 to 2. Now we have to consider the first problem, integral del dot f bar dv over the volume V. Del dot f bar, clearly it is a scalar function. Del means it is a differential operator. So now I will calculate this del dot f bar. Now del dot f bar is equal to I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z. The dot product with f bar. What is f bar? The f bar is 2x square minus 3z into I bar minus 2xy into j bar minus 4x into k bar. So on operating with the dot product I bar, dou by dou x of this one, this is 4x only. Dou by dou x of this one, I bar dot 1, I bar dot j bar 0, I bar dot k bar 0. Only dou by dou x of this one 4x plus j bar into j bar dot j bar 1, dou by dou y of this one, that is minus 2x only, plus k bar dot k bar 1 and minus 4x bar. That means what? Dou by dou z of this one, 4x, this is 0. That means 4x minus 2x, that is equal to, what is the value? This is 2x only. 2x square minus 3z I bar minus 2xy j bar minus 4x k bar. And making dot product I bar dot I bar 1, dou by dou x of this whole thing is only 4x. I bar dot j bar 0, I bar dot k bar 0. Dot product because you are calculating. Then j bar dot I bar 0, j bar dot j bar 1. That means dou by dou y of this term. That will be minus 2x. Plus k bar dot k bar 1, dou by dou z of 4x, that is 0. So that del dot f bar is equal to what we obtained is 2x. So now we have to integrate the function. Now integral del dot f bar dv over the v is equal to integral, triple integral, it is 2x dx dy dz, and over the limits z varies from 0 to, what is the upper limit? 0 to 4 minus 2x minus 2y. 4 minus, so I will write here 4 minus 2x minus 2. And y is a single, z is a two variable limit. Z is a function of x and y. That means what? You have to integrate the function first with respect to z. Then what is y? Y is also a function of x. Y varies from 0 to 2 minus x. That also I will write 0 to 2 minus x. Y 0 to 2 minus x, and x is equal to 0 to 2. Here z is a two variable limit and y is a single variable limit and x is a constant. So we have to carry it out first with respect to z, then with respect to y, then finally with respect to z. I am rewriting this first 0 to 2. That means lost y 0 to 2 minus x, and z varies from 0 to 4 minus 2x minus 2y, and this is 2x with respect to dz first, then dy, and finally with respect to dx. So this is equal to integral 0 to 2, integral 0 to 2 minus x. So what is the integration? 2xz between 0 and 4 minus 2x minus 2y and dy into dx. So 2x is constant, integral dz, that is z between the limits 0 and 4 minus 2x minus 2y. So 2 can write outside 0 to 2, 0 to 2 minus x, and xz, x into what is z upper limit? 4 minus 2x minus 2y, lower limit 0 of dy into dx. So this completes the one integral. With respect to z already we have integrated and substituted the limits also. Now to take out the value 4 into 0 to 2, 0 to 2 minus x into 2 minus x minus y dy into dx. Just for the sake of simplification, I take out the value. So this is 4 into integral 0 to 2, integral 0 to 2 minus x. And what is the function value here? 2x minus x square minus xy. First with respect to dy, then dx. I will check it out. This is 2x minus x square. 2x minus x square minus xy. So 2x minus x square minus xy dy dx. So 4 into integral 0 to 2. Now on integrating with respect to y, because y is a single variable limit, we have to integrate as per order. We have to integrate the function then with respect to y. Then what is the 2xy minus x square y minus xy square by 2. Limits are 0 to 2 minus x of dx. So now I have substituted the I have done the integration with respect to y. So now I substitute the limits. What is upper limit? 2x into 2 minus x. That is one limit. Minus 2 minus x into x square. X square as it is. Instead of y, you write 2 minus x minus x by 2 into 2 minus x whole square, and lower limit 0, 0, 0. So we need not to consider any term, the lower limit. So what is this? 4 into integral 0 to 2. We can take 2 minus x outside. 2 minus x is common. So on taking out, we will get 2x minus x square minus x by 2 into 2 minus x of dx. Just for simplification purpose. So you see inside the bracket 4x minus 2x square minus 2x plus x square by 2. I'm simplifying LCM 2. Inside the bracket 4x minus 2x square minus 2x plus x square. So what is the value? Minus x square minus x square minus 2x square plus x square minus x square, 4x minus 2x by 2. So I can write it as 4 into integral 0 to 2 minus x, and this is also 2x minus x square by 2. We can write 2 outside. So on taking out 2 again here, or I can write, you can multiply and do that. So now I will simplify, that is integral. So now what to do? I will do here only. So 2 into integral 0 to 2, and on multiplying 2 into 2x, that is 4x minus 2x square minus 2x square minus 2x square plus x cube plus x cube. Am I right? So this is 2 into x cube minus 4x square plus 4x of dx. The limits are 0 to 2 only. So that is equal to 2 into integral 0 to 2. So x cube minus 4x square. This I will integrate directly. Now I will do the integration here directly. 2 into x power 4 by 4. That is first term integration. So see this term, x cube integration x power 4 by 4 minus 4 into x cube by 3 plus 4 into x square by 2 between 0 and 2. So what are the limits? 2 into, this is 2 power 4, 16 by 4, this is 4. 4 into 2 cube, 8 into 4 by 3, 32 by 3 plus 2 2s are 4 already, 2 square 4, 4 2s are 8 and lower limit is 0. So what is the value? 2 into 12 minus 32 plus 24 by 3. So 2 into, this is 36 minus 32, 4 by 3. So this is equal to, the required solution is 8 by 3 is the required answer. That is the volume integral for a del dot f bar dv. Similarly, you can calculate del cross f bar also. Del cross f bar also. So that can be done by using, how I will show that. So how you can, I will give suggestion to you could do it your own. I will, how to consider del cross f bar dv over v. So we know that del is a differential operator, I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z. So this is the function. And f bar is the given function, f1 I bar plus f2 j bar plus f3 k bar, whatever you have the function. Then del cross f bar. How to calculate del cross f bar? This is determinant of I bar, j bar, k bar, and it is dou by dou x, dou by dou y, dou by dou z, and this is f1, f2, f3. So in this way you can calculate the cross product of the two vectors. Then it is I bar into, so on discarding this column and this row, dou f3 by dou y minus dou f2 by dou z. That is the first term. Similarly, minus j bar into, on discarding this column and this row, dou f3 by dou x minus dou f1 by dou z. Plus k bar into, what is the last column? This column and this column on discarding, dou f2 by dou x minus dou f1 by dou y. So this is the del cross f bar. Clearly it is a vector function because it is containing I bar, j bar, k bar. So already given f bar, the vector, then find del cross f bar. Del cross f bar means the determinant of I bar, j bar, k bar, dou by dou x, dou by dou y, dou by dou z, and write the I bar coefficient, j bar coefficient, k bar coefficient, and simplify. You will get a vector point function as a del cross f bar, write it as f1 bar. So you will get some other vector, other vector, small f bar. Now you have to find integral f bar dv. F bar dv over the same limits. So what are the triple integral limits? Already we have seen in the previous case, triple integral f bar dv. This is z limit, this is y limit, this is x limit. X 0 to 2, y 0 to 2 minus x, z where is 4 minus 2x minus 2y. So based on these limits, you integrate first with respect to z, because z is a two variable limit. Integrate the function with respect to dz first, then dy, finally with respect to dx. So in this way, you integrate the given function and get the solution of the volume integral. So with these words, I conclude my volume integral. In the next session, we will do some more problems on vector integration. So here you have to find the surface limits. So based on the limits, we integrate the function with respect to z, y and x, and you will get the required result. So thank you everyone.
Like, share and subscribe. Hit the bell icon for more updates.